in statistical methodology. When you go for analysis of numerical data, we use different patterns of analysis. We carry out analysis of central tendencies, analysis of variation, different types of tests to study the significance of the variations, and of course, when you want to compare the different treatments simultaneously, you go for analysis of variance. But in nature, you can see that the variables are not usually independent. The characters are not independent. Quantitative variables show different levels of interrelationship due to different reasons. For example, all of us know that rainfall is related to crop production. Or when you come to human characters, for example, height of human beings and body weight of human beings have a relationship. So there are such several variables that show interrelationship with each other. And in such cases, we will say that the variables are correlated. And under some circumstances, certain variables will be showing a cause and effect relationship. When one variable changes, there will be a corresponding change in the next variable. If you are considering two variables simultaneously, for example. And that type of cause and effect relationship is also there in nature. So there are different types of interrelationships. So the present module of data analysis deals with correlation and regression. Studies on correlation and regression of variables. So as we mentioned in the beginning, correlation is the interrelationship between different variables. In a population, when you study different variables, we can see that several variables are interrelated and there are different trends of interrelationship. Sometimes the relationship may be positive in nature, that is, when the magnitude of one variable increases, the value of one variable increases, the value of the second variable also increases. So in some cases, there is a negative relationship. When one variable increases, the other variable decreases simultaneously. So there are different types of relationships, a positive relationship between variables or a negative relationship between variables. And some variables of course show no relationship at all. And the study of interrelationship of variables comes first, and it is the study of correlation between variables. So correlation analysis. So as we have now seen, there is positive correlation and negative correlation. And in positive correlation, when there are two variables, when the first variable increases in magnitude, the second variable also increases in magnitude. And when the first variable increases, if the second variable is getting reduced one by one or getting decreased in magnitude one by one, it is negative correlation. And you see, the correlation may be of different types, positive or negative. And you see there is perfect correlation and imperfect correlation. Perfect correlation means when one unit of the variable x increases, one unit of the variable y also increases. So there is a direct relationship in the variation, or it is perfect. One variable increases at a particular level, there is a corresponding level of increase in the second variable, and that is perfect correlation. And it may not be always the case. It may vary sometimes. And there is such a relationship when variable x increases in magnitude, variable y also increases. But it is not linear. It is not as mentioned in the case of perfect correlation. There is no chance of increase of 1 unit in the case of variable y when 1 unit increases in the case of variable x. So this type of correlation, this type of relationship between the variables x and y, we can call it imperfect correlation. So there is perfect correlation and imperfect correlation. When we study correlation between two variables, for example variable x and y, they have certain relationships, but it does not mean that there are no other variables correlated with them. There are other variables also. If there are x and y, there will be a third variable z, for example, and z may be also correlated with x and y or x or y. So the correlation of one variable to the other may not be perfect also, and it will have interrelationships with other variables. And if you are studying the interrelationship between x and y by controlling or after controlling the third variable or after controlling the other variables, we call it partial correlation. It is the correlation between any two variables. For example, correlation between variable x and y by controlling the effect of the other variables which are related to these x or y, and you are controlling certain variables, and they are controlled variables. They are called controlled variables or covariates. And if you are controlling the change in the case of the covariates, and if you are studying x and y, you will say that you are studying partial correlation. And correlation is just the relationship between different variables, and the relationship may be positive and perfect, or positive and imperfect, negative and perfect, or negative and imperfect. And one of the very useful method of representing variation is in the form of scatter diagrams. Scatter diagram is a diagram in which the variables are plotted on the x-axis and y-axis of a diagram, and the corresponding frequencies or the value of y corresponding to the value of x is plotted and a diagram is drawn. It is called a scatter diagram. And you can draw a scatter diagram of variable x and y in the case of a positive correlation, in the case of a negative correlation, and also even when there is no correlation also, you can draw a scatter diagram. Or in other words, using a scatter diagram drawn from a set of data, you can comment on the nature of correlation that is present. In the case of a scatter diagram in which there is positive correlation, in the case of a scatter diagram in which there is perfect positive correlation, you will be getting a straight line starting from one corner of the graph, moving to of the diagram, moving to the other corner diagram. And when there is imperfect positive correlation, there will be certain variations, certain fluctuations shown by the line. Even then, you can draw it. Means starts from the bottom left side to and moves to the upper right side of the graph. In the case of a scatter diagram in which you are representing negative correlation, the diagram will be in the opposite direction. It will start from the top side of the left to the bottom side towards the right. And when there is no correlation, you can see your points that you have plotted on the graph will be scatteredly arranged. So from a scatter diagram, you can find out the type of correlation or the nature of correlation to some extent. But in practice, the usual way of finding out the relationship by correlation analysis is by finding out the correlation coefficient, by calculating the correlation coefficient. The correlation coefficient is a statistic calculated to find out the level of interrelationship between two variables under study. And the correlation coefficient ranges from -1 to +1. If the correlation coefficient is -1, it indicates that there is perfect negative correlation. And if the correlation coefficient is +1, it indicates that there is perfect positive correlation. And if the correlation coefficient is 0, it means that there is no correlation. Correlation coefficient ranges from -1 to +1. Starting from -1, you can get -0.9, -0.8, -0.7, -0.6 like that. Or you may get, starting from +1 downwards, you can get +0.9, +0.8, +0.7, +0.6 like that. So you get always a value in between +1 and -1. And correlation coefficient, if it is high, either near +1 or near -1, we will say that there is high positive correlation or there is high negative correlation. Correlation coefficient is calculated using a formula, and the formula is R is equal to small r represents correlation coefficient. Small r is equal to sigma small x small y divided by square root of sigma small x square into sigma small y square. So R is equal to sigma small x small y divided by square root of sigma small x square into sigma small y square. And small x is the deviation of x bar from each and every value of x, the first variable, and small y is the variation of y bar from each and every value of the variable y. Of course, x bar stands for the mean of the first group of data or the first character, data on the first character, the first variable, and y stands for data on the second variable. So now you can move to the calculation of correlation coefficient in a particular case. An example is given here. Data on the plant height of a plant variety and the number of fruits produced. Plant height and the number of fruits produced in the case of a plant variety. And you are asked to find out the correlation coefficient. Plant height is given in centimeter and it is taken as x, the first variable, and number of fruits is taken as y, which is the second variable. So the values are given. The first step is to plot the two sets of data, the two variables x and y, in two adjacent columns in a table. And then you have to calculate the mean values, x bar in the case of the first variable x and y bar in the case of the second variable y. And since these are unorganized data, x bar is equal to sigma x by n and y bar is equal to sigma y by n, and example, in the given example, x bar is equal to 50 and y bar is equal to 27. You are given two sets of data and you have to see what is the level of interrelationship, what is the correlation between, nature of correlation between rate of change in the variable 1 and the variable x and the rate of change in the variable y. And you have the next step is to calculate x minus x bar and y minus y bar, and they are denoted by small x and small y. Small x, that is x minus x bar, is equal to, is calculated in each case of x, and you get, since there are 10 plants, you get 10 values, and the next value, the next case also you get 10 values of small y. So values of small x and small y have been calculated. And the next step is to calculate xy, x into y. So xy in each case corresponding to each row is to be calculated. And after calculating xy, you are going to calculate the x square and then the y square. So you have xy, x square and y square. And since your formula for the calculation of r, small r, the correlation coefficient is r is equal to sigma xy divided by square root of sigma x square into sigma y square. You have to find out sigma xy, sigma x square and sigma y square. And substituting in the formula, you will get sigma xy is 252 divided by square root of sigma x square into sigma y square. Sigma x square is 330. Sigma y square is 196, and after calculation you get plus 0.99 as the correlation coefficient. It means that it is lesser than plus 1, but it is 0.99. It shows that there is very strong positive correlation between plant height and number of fruits. In other words, you can say that there is 99% positive correlation between the two variables understood. Then after finding out the correlation coefficient, the next step is to interpret the interrelationship based on the correlation coefficient. And for their purposes, the value of r, the value of correlation coefficient between 0.9 and 0.1, whether it is plus 0.9 or minus 0.9, like that. The values between 0.9 plus or minus 0.9 to 1 we consider as showing very high positive correlation or very high negative correlation. If it is between plus or minus 0.7 to plus or minus 0.9, it is interpreted as high positive or negative correlation. If it is plus or minus 0.5 to plus or minus 0.7, it is called usually moderate positive or negative correlation. And when it is plus or minus 0.3 to plus or minus 0.5, we say that there is no correlation between the two variables. And when it is between 0 and plus or minus 3, we say that there is only negligible correlation. And that's the general way of interpreting correlation based on the correlation coefficient. But if you want to statistically measure or statistically test the significance of the correlation coefficient, we will go for a t-test. And here the formula of t that is used is t is equal to square root of r into, t is equal to r into square root of n minus 2 divided by 1 minus r square. T is equal to r into square root of n minus 2 divided by 1 minus r square. Here r is the correlation coefficient, n is the number of observations, and in this case, significance of t is tested at n minus 2 degrees of freedom from a table. After calculation of the t value from a table, you can test whether the t is statistically significant or not. So now we have seen correlation analysis in which the interrelationship between two variables is being analyzed, and it may be of different types, and you can calculate the correlation coefficient. And after that, we move to regression analysis. And regression analysis is the analysis of the cause and effect relationship between two variables. Sometimes due to correlation between variables, x minus x bar is equal to r into sigma x by sigma y into y minus y bar, and that's the regression equation of x on y. And regression equation of y on x is like this: y minus y bar is equal to r sigma y by sigma x, small sigma, small x, small y, r sigma y by sigma x into x minus x bar. Y minus y bar is equal to r sigma y by sigma x into x minus x bar. So there are two regression equations. Regression equation of x on y is x minus x bar is equal to r into sigma x by sigma y into x minus, into y minus y bar. If the interrelationship of the correlation is positive, if the correlation coefficient is positive, the regression coefficient also will be positive. There is linear regression and curvilinear regression. In linear regression, by unit change in the case of the first variable, initially that same pattern will be shown by the second variable also, but after a particular level, that change is not made. Either there is no further change in the case of the variable b, the variable y, or in some cases there is a reduction x on y and the regression equation of y on x. And regression equation of x on y is like this: x minus x bar is equal to, or the rate of change in the first variable, x minus x bar is equal to r into sigma x by sigma y small sigma, small x, small y. Or is the regression coefficient calculated? Regression equation of y on x is y minus y bar is equal to r into sigma y by sigma x into x minus x bar, as shown here. And in these equations, you see r into sigma x by sigma y is known as the regression coefficient of x on y. R into sigma x by sigma y is known as the regression coefficient of x on y. And then the regression coefficient of x on y is also known as bxy. And r sigma y by sigma x is known as the regression coefficient of y on x, and it is also known as byx. And you can calculate these two coefficients. The regression coefficients can be calculated. The regression coefficient in the first case, regression coefficient of x on y, r sigma x by sigma y, is equal to sigma xy divided by sigma y squared. You know all the values are small x, small y, etc., and they show the deviations x minus x bar or y minus y bar. And there is a relationship between the correlation coefficient. There is a relationship between the correlation coefficient or the coefficient of correlation and the regression coefficients. And coefficient of correlation is equal to square root of bxy into byx. Correlation coefficient is equal to square root of bxy into byx. Sigma xy divided by sigma y square gives the regression coefficient of x on y, and sigma xy divided by sigma x square gives the correlation coefficient of y on x. So you can calculate regression coefficient of x on y and regression coefficient of y on x, and if you know the regression coefficient, it is a particular value, and from that you can develop a formula which can be called a regression formula or a prediction formula. And here bxy is the regression coefficient of x on y, and byx is the regression coefficient of y on x. So now we have gone through the preliminaries of correlation analysis and of course regression analysis. And correlation analysis is the study of interrelationship between characters, and it may be measured using correlation coefficient, and the correlation coefficients may vary from -1 to +1. And regression analysis is the analysis of cause and effect relationship between variables, and it may help you in predicting the unknown variable if the known variable is known. And there are two regression equations, regression equation of x on y and regression equation of y on x. So that is about correlation and regression. Thank you very much for listening.